Hey, welcome back to Noah Reads Wikipedia, where I, Noah, read Wikipedia. Today's topic is one of my favorites. If you know, you know. It's about these little insect guys right here, weevils. And I'm going to read you a little bit about them. Weevils are beetles belonging to the superfamily Curculionidae, known for their elongated snouts. They're usually small, less than 6 millimeters, or a fourth of an inch in length, and are herbivores. Approximately 97,000 species of weevils are known. They belong to several families, with most of them in the family Curculandia, the true weevils. It also includes bark weevils, which, while morphologically dissimilar to other weevils and lacking the distinctive snout, is a subfamily of Curculandae. Some other beetles, although not closely related, bear the name weevil, such as the biscuit weevil, which belongs to the family Pinodontae. Many weevils are considered pests because of their ability to damage and kill crops. The grain or wheat weevil, I can't pronounce that, damages stored grain, as does the maize weevil. I also can't pronounce that. Among others, the boll weevil, Anthonomius grandius, attacks cotton crops. It lays eggs inside cotton balls, and the larvae eat their way out. Other weevils are used for biological control of invasive plants. A weevil's rostrum, or elongated snout, hosts chewing mouthparts instead of the piercing mouthparts that proboscis possessing insects are known for. The mouthparts are often used to excavate tunnels into grains. In more derived weevils, the rostrum has a groove in which the weevil can fold the first segment of its antennae. Most weevils have the ability to fly, including pest species such as the rice weevil. There are a significant number of flightless, such as the genus Ortohunchius. One species of weevils, Osteoplatypus incomprehentus, exhibits sociology, which is the highest level of organized sociality, one of the few insects outside of Hematora and the Isoptera to do so. Taxonomy and phenology. Because so many species exist in such diversity, the higher classification of weevils is in a state of flux. They are generally divided into two major divisions: the Orthocrustari, or primitive weevils, and the Gonatorai, or true weevils. E.C. Zimmerman proposed a third division, the Heteromorphi, for several intermediate forms. Primitive weevils are distinguished by having straight antennae, while true weevils have elbowed, geniculated antennae. The elbow occurs at the end of the scape, first antenna segment in true weevils, and the scape is usually much longer than other antenna segments. Some exceptions occur, such as in nanophyll primitive weevils with long scapes and genital antennae, which while among the true weevils, Gonoptera and Ramphus have short scapes and little or no elbow. A 1995 classification system to family was provided by Kerschel, with updates from Marvaldi in 2002, and was achieved using phylogenetic analysis. The accepted families were the primitive weevils, the Anthrabidae, the Atalabidae, Bieldae, Brentidae, Caridae, and Nemonchidae, and the true weevils, Curculandae. Many other weevil families were demoted to subfamilies or tribes. Further work resulted in the elevation of Semeridae to family from placed as a subfamily of Nemonchidae in 2017, and the recognition of the Cretaceous age family Mesophiltidae in 2018 from Burmese amber. The oldest weevils date to the middle late Jurassic boundary, found in the Karabatso Formation of Kazakhstan, the Shartag locality of Mongolia, the Daohulgul locality in Inner Mongolia, China, the Tarboro site in Australia. The extinct family, Oberonidae, with species dating from the latent stage of the Jurassic, through tentatively the Oxfordian, have sometimes been considered weevils. Genera of the family have only been found in 3 formations in Kazakhstan, with most named in 1993. However, their phylogenetic position is contested, while others considered a part of Arachnostigmata. The interfamiliar relationships of Cornicona have been generally well resolved. The phylogeneity based on phylogenetic data is suggested below. And then we have up top, and then we have the data with the Killenberg data, Nymon-C data, Antribidae, Bellidae, Atelidae, Caridae, Brentidae, and Kirkonidae. And then here are some of the families of weevils. We have true weevils, as spoken here, which are the Curliconidae. And families, we have the Atolinidae, which are leaf-rolling weevils, Bellidae, primitive weevils, Brennantae, straight snout weevils, Caridae, Kimberidae, Curliconidae, true weevils. This which means it's extinct, Mesophilidae. And then sexual dimorphism. Raphophanolargisis exhibits an extreme case of sexual dimorphism. The female rostrum is twice as long and its surface is smoother than its male. The female bores egg channels into the bud of Elysia rosae, thus the dimorphism is not attributed to sexual selection. It is a response to ecological demands of egg depositation. Another example of extreme dimorphism is in weevils is that of the New Zealand draft weevil. Males measure up to 90 millimeters, 3.5 inches, and females 50 millimeters, or 2 inches. Although there are some extreme range of body sizes in both sexes. And here are some references and further reading. And that's just a little bit about weevils. Thank you for listening.